everyone, my name is Dmitry Gromov, and in this lesson I'll show you my approach to working with USDSen in Houdini, and we will talk about Karma XPU. Let me show you final result. In this part 1 we will go through layout and assemble some assets and do shading for them. But before we start, a couple of words about my experience with Karma XPU. For myself, I concluded that it is extremely important when everything in stage set up as efficient as possible. And at least all the assets are USDs and all textures have MIP levels. In this case, your experience with XPU may be really smooth. Also, I wanted to show you a collection which I used for this project. You can see it on the left side. And we're going to prepare some of these assets in this part. On the right side you can see references for overall mood, maybe except this one, because this picture is from original collection and I just like this greenish, which I wanted to see in my shot too. Yeah, that's it. See you in layout section. Let's start with the base layout. First of all, I want to say that I got quite a lot of iterations in OBJ before I passed everything to stage. And I assembled some kind of prototype layout before working with it in lobs. We're not going to assemble the whole layout from scratch because it will take a lot of time, and I believe that everyone knows how to transform objects in 3D space. Instead of this, I'll show you what exactly I did in this layout and how exactly I worked with assets. So let's start from the beginning and let's imagine that we have approved layout in OBJ, and how can we transfer this data from OBJ to stage. One of the ways can be create sen import node, lob node, and we have some variations here, all cameras, lights, materials. If you're not sure, let's use this one for example. And if we specify everything necessary here, we can transfer data from OBJ to stage and work with it in this sen. But I do not recommend go this way. Instead, I encourage you to use USDs in your sen and to prepare for every of these asset base geometry USD layers and work with them in lobs. That's exactly what I did. But let's imagine now that we already have all these assets prepared as geometry USDs, and I'll show you how I imported these USDs in stage and how I worked with them with the base layout. You can see here just a sequence of nodes, and actually when you work in Solaris, that's how it really works. If everything prepared properly, it's just a sequence of nodes which you rendering in the end. It's an ideal situation, of course. Let's start from the beginning, and first thing I'm starting with is declaring our sen structure, sen scopes. For these purposes, I'm creating primitive lob node with the primitive type scope. That's just our sen structure, and I think it's a good manner to work like this, because in this case you can easily pass your data to FX, for example, and to other departments, and that's really convenient as for me. After that, I'm referencing our first asset, and this is the rod. This is the base geometry of our rod. You can see that here we load in rod geo USDC. Actually, it's not just a plane. I'll show you what is it. It is an asset with the 3 primitives inside. Let me show you them, and this is our base rod, which we really see. I splitted the whole rod into these parts because I wanted some of them have displacement and some of them do not have displacement, but we'll talk about it later. Yeah, this is a part which will have displacement. This part won't have displacement, and this is some kind of proxy water geometry. This is just the bounding box for our main rod part. Let's close our rod. So this is our first asset here. After that, I'm referencing buildings. Here we can see our hero asset, hero building I mean, on the right side. After that, a couple more assets. I'm sublayering them, and after that I'm plugging them into asset reference second input. And you can see that we use the same asset 2 times here, and of course in this case we will need to mark them as instanceable to make it more efficient, but about it later. A couple more buildings, and yeah, that's it. So after we reference all the our buildings, we go into props, and here are street poles. After that I'm referencing bikes, and in the end 2 more assets. First one is street prop barrier here. Yes, this small barrier which we barely see actually, but I decided to leave it here. And umbrella on this bicycle. I think this one looks really good. And after we referenced all these assets, we are going to effects, but not in layout, to lighting. For this base lighting I just used environment dome light with a single HDR. And in the end we just creating Karma XPU and rendering it. Let's start rendering and I'll show you what I have here. Here is the final result without materials, and let's talk about it one more time. So instead of importing some data from OBJ to stage, I prefer using USDs and work only with them in stage. And I think it's the best way here. Also, if I may want to bring some materials here for this, for instance, for this Tokyo bike geometry layer, all I need to do is just to apply these materials here, or load the final USD instead of this gel layer. And all the same things with all other assets. Let's start assets preparation process from something really simple. And this is my setup, which I use for almost every asset in this project. You can find quite a lot of different setups on the internet, from side effects for example, but I decided to stay with this simple one. We will make it more complex later when we will prepare assets, but for now let's stay with this. Everything starts with this null with asset name string. This string reads heap name and removes 5 symbols from the right side. And these 5 symbols are version 1, and in this case we have asset name template. After that I use primitive lop and creating asset structure using this asset name. Here in this section you can see geometry layer preparations, and in this section we have material layer preparations. And after we prepared both of them, we can sublayer them into this structure. After that we can set some render geometry settings for this asset. It may be limit settings, for example, if you want them to be with this asset, and if you do not want them to specify later in master sen when you are doing lighting. But I decided to set them later in lighting instead of setting them for every asset. Some more settings here. I mean, we can use configure primitive for marking this asset as instanceable if we want, and in the end we just saving this asset on disk. But when you save in this final USD, you also have this material layer and this geometry layer saved on disk too, in the same folder. Let me show you this. You can see it here. Template, this is our final USD, this is geometry layer, and this is material layer. Let me show you what we have when we sublayer on our final USD and separated layers. This is our final USD, and we got both geometry and materials here. If we see these sublayers, first we read the geometry layer, and you see geometry only, and here we can see material layer without geometry. If we combine them, we have the final USD. So in the end, you can use your final USD or combination of these two sublayers. And when I worked with layout, what I did, I just left this material library empty and saved the final USD, and I got these geometry layers for every asset. So that's exactly what I used for base layout. Let's go through the whole setup from the beginning to make everything clear, and we'll start with geometry layer. First node here is soft create. Let's dive inside. Here we can find some nodes from my template which we're not going to use now, and I'm just leaving them disabled. The next is test geometry rubber toy node, and this is our geometry with disabled shaders. I don't want any shaders to be applied here. After we have geometry prepared, we need to specify path attribute to create the base structure for geometry layer, and I did it with attribute wrangle run over primitives and created string path attribute, which you can see here. Let's see what we have now in SandGraph tree. Now we can see this mesh primitive, and here is our geometry. But sometimes we may want this geometry to be separated into parts, and in this case we need to modify path attribute. I just used connectivity node with connectivity type primitive. We can enable it, and now we see class attribute for every part of this geometry, and just modifying path attribute like this. Let's see what we have now, and now we have separated geometry and separated primitives here. Let me find the body. Yeah, all works well. Actually, sometimes we don't need to specify path attribute because, for example, in component builder setup, let me create it. Component builder setup. We create in geometry inside this component geometry node, and in this case we already have prepared structure. All we need to do there is just to create name attribute inside for geometry, and that's it. We'll have the same result, but I decided to do everything from scratch. We will use some parts of this component geometry component builder setup later, but for now, okay, we prepared geometry. After that we can apply some USD stuff using configure primitive loop, and I used only two options here, purpose and primitive type, and of course I choose primitive which I want to configure. Purpose, you can see the options here. For example, if we set it to render, so this geometry will be for final rendering. Proxy is for proxy visualization in viewport, for example, and yeah, that's it. Let's leave it as a render. And where can we switch these things in a viewport? We can switch it here. For example, I'm removing this and we don't see any geometry. Okay, next step is configure layer, and this step is quite important because here we set in the path for geometry layer we creating and the default primitive. Yep, that's it. This save path is the same folder as our final USD, but different USD name. You can see it here. After that we can sublayer it into our structure and work with material layer. So what we have in this section? In this section we have material library node, in which we have just 3 subnetworks with simple materials. After that we have assign material node, and we assign in, let me show you, we assign in green color to the body, red to these legs, and so on. And configure layer node. This is all the same thing as in geometry layer. I mean, we just set in the safe path for material layer. And also here we have layer break node. Layer break node allows you to isolate your layers, and in this case everything above this layer break node won't be included into this material layer. That's exactly what we want. After we prepared material layer, we sublayer in it too, and just saving the final USD. Let's have a look at more complex example, and this time we will work with hero building. Let me show you render. We have quite a lot of different primitives here, materials for them, and of course really a lot of textures. And I'll tell you how I worked with this amount of data. Of course, we're not going to do shading for every of these parts, because some of them are really simple and not interesting. Instead of this, we will work with transparent curtains and I think with lanterns. But before we are diving inside Socrate, let's have a look at this setup again. It's almost all the same as in previous example. Asset name, create and structure, geometry layer, here we configure in material layer, sublayer in both of them, and do some cleaning stuff. I mean, I use prune lop node to make some primitives invisible. We're not deleting anything in USD. And my simple look development setup. Okay, let's dive inside and see. Here we can see geometry preparation steps, and almost all of these steps are just for fixing or for some fixing and assigning some attributes that we need in shading later. Let's start from the beginning. This is our path attribute, which is more complex than in previous examples, but nothing special. After that, I'm recomputing normals, removing unnecessary attributes, creating rests, but actually we don't need to do it here. We can do it in shading using MarterialX position node with object space option. It will work. And group delete to remove some unused groups. After that, this section is for fixing the UV coordinates with some simple box mapping. And let's talk about attributes which I assign. Let's have a look at this geometry. Yeah. Let's make it like this. So I'm creating attributes with attribute wrangle. You can run over points or primitives. It will work in any case. I'm creating 2 attributes. First is float trans attribute, and the second is integer thin attribute. Let's start with this one. This thin attribute will tell the shader if geometry is thin-walled or not. Generally, thin-walled means that geometry do not have thickness, and we can see it here. How can we see it? From this side, we can see simple white polygons, but from the other side of this geometry, it is tinted with blue. This side is front face and this side is back face. And in this case, we can say that this geometry is thin-walled. The second one is for, this float trans attribute is for translucency, and we will use it to mark some geometries as translucent. And actually for transmissions too. We will talk about it in shading. Also, I assigned the same attributes on these lanterns. All the same attributes, I mean back faces inside and front faces outside. Okay, after that, after all the preparations, I just save this geometry as bitgeo and passing it to lobs. Let's have a look at materials, and diving inside material library we can find 34 different materials, and 34 is only for this asset. Actually, I had to tweak almost all of them manually. I understand that there are some scripts that can help me with it. I mean script converters, for example, from principal shader to MarterialX, but these scripts are not ideal, and in this and anyway you will need to do some tweaks manually, and I just decided to do it manually from the beginning. And of course I'll tell you how I worked with this amount of data, because I had to do some automatization stuff to make it easier working with this amount of materials. Okay, let's go outside for now and have a look first at primitives on our geometry. We can see here, let me show you, we can see this amount of primitives and how I worked. I know that, for example, for this primitive AC units we have corresponding textures. I did the following. I know that we need to assign material to this AC units primitive. I found corresponding textures for these primitives and put them into the folder which I prepared. Let me show you. Yeah, in this folder we have textures for all the primitives on this project, quite a lot of them. Let's find this one, AC units. So we have named primitive, we have folder with textures with the same name, and diving inside we can find textures that has the same name. Okay, after we have this folder with all of these textures, we can look at template which I used. Let's have a look at this one. Or maybe we can use, yeah, let's have a look at material. After that, I'm just creating subnetwork with the name of this primitive. And this is final material for this geometry. Let's dive inside, and here we have some MarterialX image nodes, and we have this null which reads material name. And after it read material name, I just construct the path to the textures from the path to the folder and this name. And that's what I have. For example, for this particular primitive, we have the path to the base color texture, AC units, base color, ACCG. Of course, all textures are converted to ACES, I mean necessary textures. Okay, all the same thing with roughness here. And for this primitive, we also have normals. And all I need to do for the next primitive is just to copy this template and rename this subnetwork. That's how I worked with textures and materials. Before we continue, let's have a look at this MarterialX standard surface node. Base color, nothing special here. Specular contribution, coat layer, which we will use for wetness later, and interesting things here are affect color and affect roughness. After that, transmission, I'm not closing it now. Sheen for some fabrics, subsurface, I'm not closing it too. Emission, thin film for some bubble-like materials or oil spots on the water, for example. And geometry tab. Here we can find thin walled option. This thin walled option affects two tabs here. First, transmission, and the second one is subsurface. If this is disabled, so our transmission is just a regular refractions with distortions, I mean something glass-like. And in case of subsurface scattering, if this thin wall is disabled, then this is just a regular subsurface scattering. I mean subsurface for objects with thickness. But if we enable this, so in this case this transmission becomes thin walled transmissions and do not have distortions. Also, in case of I mean in this case it will be like architectural glass or some other materials which do not have distortions but transparent. Okay, and next is subsurface, and if thin wall is enabled, subsurface becomes translucency, and we have only subsurface parameter available for editing and subsurface color. That's all I wanted to show you before we go in further to shading. Let's do shading for transparent curtains. I'll do it in separated material library and assign material nodes. Also, I did some preparation stuff. Yep, just isolated these curtains. And one more thing is that I'm going to use CPU engine, because when you're working with XPU and changing something in shading, for example, you will need to wait until data is updated in GPU. I don't want to wait it. That's why I decided to use CPU for some look development and assigning and tweaking materials and so on. But final rendering will be with XPU. Let's dive inside material library. Here we got just an empty template, and these materials are ready. Sometimes I will go inside and look if everything is okay. And these templates are just reading textures. So I already know that we have textures in corresponding folder on disk, and all we need to know is just to set the proper name for this subnetwork. But for now, let's start rendering. Now it's just these curtains now do not have any materials. That's because this name. Restart. And now we have textures which we got on disk. Okay, let's have a look at AOVs we have. Of course, all the beauty passes here. Diffuse. Let me make it brighter. Diffuse. Emission, we do not have any emission. Chord, we do not have any chord layer for now. Reflections. Actually, these reflections looks quite bright, and later we will see why. Glossy transmission, no transmissions for now, and also actually we have opacity texture here, which I need to plug in. And let's see now what we have. Yeah, now they are transparent. But I don't like to use opacity textures on the whole objects, because it removes all these contributions. I'll show you. For example, if we will look at combined glossy reflection and we will unplug opacity, it will be brighter. So using opacity texture on the whole object, I think it's not a good idea, because we cannot understand if shading is proper or not. But in cases with some maybe small objects, I mean foliage, when we have opacity textures for borders, in this case that's all good. So what's the next step here? Yeah, you see these reflections, and why it is so. Let's have a look first at textures that we have. Base color, emission, of course we don't have emission for this. Height, metallic, and that's it. Actually now these curtains have metallicity, and actually that's not good. We will need to do something with this, and that's why we have these bright reflections, because metallic reflections are really bright, but the electric reflections not. Let's have a look at other textures, normals, we will use them. Opacity, yeah, we will use this texture too, but not for opacity, for other interesting things. Refractions, nothing here, and roughness. We will use this one too. So, base color, opacity, roughness, and normals. That's what we are going to use. Let's go to the beauty path, and first thing I'm going to do is just unplug everything I have plugged in. Let's remove this. Okay, and I do not want metallicity texture affect our material. For that, I'm creating MarterialX constant and setting it to 0, plugging in, and now we will have just dielectric reflections. That's how it should be. Okay, diffuse is still here. And the next step is transmission. I think we need to play with it and see what we will have. Let's set it to 1. Now we can see these refractions. If we will look at the lossy transmission AOV, we will see these refractions. But actually, for now, I see distortions here. That's what we need to avoid. And for this, of course, we're going to the geometry tab and find this thin walled option and enables this. Let's have a look at it now, maybe from this side. Yep, and let's wait a bit. Let's wait a little bit. Maybe some region. What else we have here? Yep, for now everything fine. Now we can see we need to look at AOVs, and now we do not have any, we do not see any diffuse because transmission value is 1, and we do not have any diffuse contribution anymore. Reflections. Now we have these glossy reflections here. And let's have a look at transmission AOV. Now it's too rough, and we need to do something with this. How can we affect transmission roughness? There are two options. First is, and I would say that's the main option here, is to use specular roughness, because this roughness affects transmission roughness. Also, we have this transmission roughness parameter, but we can read it is not implemented. Actually, as I noticed, it works with CPU now, but not with XPU. That's why we are not going to use this one. So we got only one option here. Let's set it to 0. And in this case, we see this transparency. Reflection is here, and now it's really glossy. We will need to work with this. Let's wait. Let me have a look at this. I don't remember roughness values, right? Okay, transmission, reflection, and that's what we have as final. We see these reflections, but actually nothing more. Let's use the texture which we have, I mean roughness texture, because we can see interesting patterns here and we can use them. Let's stop and plug it to diffuse roughness. Of course, we don't have diffuse now, but in cases we have it, we need to specify it too. Okay, roughness, specular, and let's have a look now. Okay, let's have a look at reflections. Now we have more matte reflections here, and also we can have a look at transmission, and now again it's too rough. What we can do? We can just create MarterialX multiply and multiply it on some value less than 1. Let's do it. 0.25 for example, and restarting rendering. Yep. Now this pattern is not noticeable, but at least we can see something through this curtain. And I think we need to reduce this low clump value. I'm using these clumps just to be sure that everything is not higher than 1 and not lower than 0, just to be sure. Okay, now we can see these patterns in transmissions, but actually not in reflections. I want them to be in reflections too. And if we see the final result, now it looks better. But actually, I'm not sure that I like these really glossy reflections. But about it later. So what else we have? Let's have a look at textures. Base color is not interesting for us now. What else? Metallic we're not using. Normals later. Opacity, right. I want to use this texture, but for transmission, but this is opacity texture. If we want to somehow use it with transmission, we need to complement this texture. I think in this case we need to use this curtain. Let's go here, and because on this one we can see interesting cell pattern which I want to see. Let's do like this, and let me have a look the fits which I used in opacity. Right, let's copy this. Of course I'll explain what does it mean. We find opacity texture. I'll stop rendering and pasting it here. Opacity is a vector value, that's why we need to separate it into vectors and just read one of them. I'm using X component, and I'm fitting it, and after that I'm complementing this. So for complement here we just can switch out low and out high values, and after that I'm going to plug it into refraction area just to see this texture now, and do transmission. Restart, and let's see the refraction area first. Now we have these black spots and black parts, and that means that we do not have transmission here, and we have also white parts. They will be transmissive. Let's have a look at glossy transmission. Now it looks interesting, not just solid, but more interesting. Let's have a look at reflections and the final result here. It's quite noisy because we're using CPU and it needs time to sample all of these parts, but everything necessary we can see. Okay, so the next step is I think reflections, because again I don't like this glossy specular, and in this case we can do the following. We can use we can close transmission, and we can use code reflection layer. Let's stop render, and I want matte reflections. For this I'm just using original roughness texture. Also this claims some kind of nulls, and I'm putting it into code roughness and setting the code value to 1. I understand that 1 is a really high value for code reflections, but let's just leave it for now. Restarting, and now we have code contribution. Let's wait a little bit. Yeah, now we have this matte reflections. I like it. And also now we can see in this reflections texture pattern, which we missed in case with glossy reflections. I mean more glossy reflections. Okay, transmissions here, chord, combined reflections, some diffuse here because transmission is not one, and some diffuse we can see. But this diffuse, instead of diffuse, we can just switch it to subsurface. But for now, let's just leave it. Okay, that's how it looks now. Interesting as for me. What else we need to do? Maybe I forgot something. Actually not. Almost everything is done here. The last thing that I want to do is to bring back normals. We need to plug in into this normal input, and of course into chord layer, chord normals. And actually that's it. Now we can do some tests with Karma XPU. Let me check if we are not missing anything. Yeah. So you see that some textures are missed, and we do not have them at all. Okay, let's stop rendering. I'm cleaning render region and then switching to XPU engine, and it's almost done. I think we can just use another dome light, but let it be rendered. Now we can see, let me just display this way. Now we can see these good transmissions here. We can see these glossy, both glossy and matte reflections. That's exactly what we wanted, and solid alpha. That's really important. Let's have a look at some diffuse, but again it may be subsurface if we may want. Reflections, chord. I see this interesting pattern. Maybe that's because of normal textures, but let's leave it for now. Transmissions looks good, and when we place some light sources behind this, that looks really great. We can see these spots from texture. Okay, let's have a look from the other lighting. We need to wait a bit. 2 errors. We can see errors in log viewer here. I think that's just missing textures, because it tells us that we have MarterialX image nodes which missing textures. That's why we can see it. Okay, let's have a look from this view. But anyway, it renders much faster than CPU. I mean, when we are working with refractions, transparency, and so on. We already see almost clean render, and I like these reflections and transmissions. Let me check it. Reflections, code layer. We can see this pattern. Transmissions, and yeah, overall looks good. The next primitive for shading is lantern. Let's have a look at it first. I'm switching back to CPU engine, and here we can see the setup for the lantern shading. It's a lantern itself, light source inside here, you can see it. It's called light bulb, but actually it's not bulb, it's just a candle usually inside this these lanterns, and these candles have a quite low color temperature. It means that they have warm lighting. And grid. The idea is to do shader which will allow light to pass through the walls of this lantern, and in this case we may see here some light from this small light source. We will see lighting on this grid, but actually there shouldn't be much transmitted light, just a little bit. Okay, let's go to material library, but before that we restart in rendering. Maybe we need to switch to this HDR. Let me check it. Yeah, I'm happy with this one. Okay, let's go inside, and now it do not have any materials because we need to rename this template. And I need to unblock this. Let's restart. Yeah, that's what we have. All the textures are there. And let's do shading. First of all, I'm starting with checking all the textures I have. Base color, of course we will use it. Emission. We have emission textures, but we won't use them. No height maps. Metallicity for these metallic parts. Okay. Normals. They looks quite aggressive, but okay. Opacity, we don't have any opacity. Refractions, of course, nothing plugged there. And roughness. Also, I know that for this geometry we have mask in the folder. Let me check it. It's just called mask. I need to copy that and let me import it and plug it, for example, into let it be refraction. And yeah, we will use this mask too. This one looks good. Okay, let's unplug everything again and start with the first base color texture. But actually first is metallicity. We can see that we have something here, but let's just leave it for now. The main thing that this metallicity texture is not affecting the lanterns, and that's good in this case, of course. We see diffuse, reflections, quite glossy, and let's step by step add more features. Okay, now we have light source inside of this lantern, but we cannot see any lighting on this grid. What can we do in this situation? If we want to light pass through these walls of this lantern, then we, for example, we can use fake caustics. And in Houdini 90.5 we had this option. We had this node, I mean 90.5 and earlier versions. But now from Houdini 20 we do not have fake caustic node anymore. And I think that is just embed in the MarterialX standard surface. What can we do? We can just play with transmission and subsurface and see if we got fake caustics enabled for them. Let's play with transmission first. Okay, let's set it to 1. And yeah, that's it. That's what we have now. Now we have contribution. Now we have this lighting contribution on this grid. But now we can see these glass lanterns, which are not looking actually like paper lanterns. And what we can do in this situation, of course, we will go to the geometry tab and mark them as thin walled, because we already seen this mesh and it's really thin walled. Okay, now we can see this light source inside, but that's still not a paper-like material, it's still a glass, just simple glass. But we can see fake caustics. What else can we do here? I think we need this base color texture to be plugged into transmission color. And now this light from the inside is tinted with this color of this texture. And I see some kind of shadow here. I'm not sure why. Maybe that's because of texture. Let me check. Ah, yes, right. This texture has this black part. Alright, so fake caustics work with transmission. But that's not looking good now. Let's disable transmission and check subsurface. When we enable thin walled, subsurface becomes translucency, and actually paper is translucent. That's exactly what we may want. Let's set subsurface. Now we can see this result, and we can see some lighting from this light on this grid. But if we see in diffuse, we cannot find it. If reflections, we find it. That's because this is indirect lighting contribution now, and if we remove reflections limit, we won't see anymore diffuse and reflections. And I can say that with translucency we do not have fake caustics. Okay, let's get back to 1. And what can we do in this situation? I can offer to do some kind of mix of transmission and translucency here. But before that, we need to plug it. We need to plug it to subsurface color. Yeah, looks good. So our next step is working with both transmission and subsurface. But for now, I think we can just disable both of them. Let me double check if everything all right. Yep. So let's bring back roughness and see what we have. But for now, I'm setting 1 for transmission. I don't like this glossiness, of course. It looks not good, and we need to bring back roughness. Specular. Yeah, much better. Now it's like matte reflections. Okay, but now we cannot see this light source anymore because we have quite high roughness of this transmissive part. What we can do, all the same as in previous section, let me do like this, and we can reduce roughness. Alright, let's make it something like this, and now we can see this light source, but that's too low. Let's stay with this value. Okay. The next step is use mask for transmission, because now it's not good, because if we do not have any light source inside, we will see these dark lanterns because they do not have diffuse. You can see no diffuse here. Let's stop and let's go to the mask and maybe put it here. I'll have a look at fits that I already have in ready shader and copy that. Let's now, it's just a fitting. Let's plug it into refraction and to the transmission input. Yep, now let's transmission here. Also we can see diffuse now. Reflection, it's still too glossy, but when we add normal maps it will be better. Oops. Let's just render this region. Transmissions are here, and as I already told, I want it also to be translucent, and for this let me create MarterialX constant and make it plug it into subsurface input and make something like 0.3. Let's restart. And now we can find this translucency in subsurface AOV. The next step is importing attributes from SOPs, and if we remember, we have attributes called thin and trans. I'll use both of them here and apply here. Now this subsurface amount applied on all of these parts. I mean on both lantern and on metallic parts. I do not want this. That's why I need both of these attributes. And first is thin walled, because again on the lantern is thin walled. And now we will see this subsurface on these parts, of course. And in this case, we can use the second attribute, which will tell which parts are translucent and transmissive. Let me stop rendering and create MarterialX multiply. Let's set it like this. And the same thing we will do for transmission. Where we can find this texture and we can move it here. This is here. Okay, let's plug it into this multiply and see what we have now. Restart. And now everything is good. We can see reflections here. We don't see any subsurface on metallic parts, and same with transmission. Okay, what's next? The next step is to make first of all is to bring back normals. Yeah, that's it. And if we look to the reference for these lanterns, we will notice that we can see these stickers. They do not have high bump values if compare with lantern surface, and also they do not allow lighting to pass through it, and that's what we are going to do for these lanterns too. Okay, how can we do it? Actually, we have base color texture, and that's all we have. We don't have masks for these stickers, but luckily these stickers are white, and in this case we can do some kind of keying here using luminance and fit operations. I'll just copy that from the ready setup and show you what I mean. Let's plug it in, for instance, haze, and let's see. Yeah, now we have this mask, and after that we can just do some more fits. For example, to create a normal mask, mask for transmissions, for translucency, and this one I'm not sure actually. I think we will use these three masks. I am copying that, and let's move it here. This mask for normals we are putting into scale for normal map node. This transmission mask we are multiplying. Let me show you this first. And I think it will be almost the same as we see now. Right, almost the same. So in this part we won't see transmission. Let me stop rendering and multiply it here. MarterialX multiply. And the next one is translucency. It's just reduced translucency value. The same thing here. MarterialX multiply. Let's plug it here and switch inputs. Should work now, and let's restart rendering and see what we have. Yeah, now it looks better, and let's check AOVs, diffuse. reflection, transmission. Now we have this sticker. We don't have transmission on this sticker. That's good. Also, we can check SSS AOV. That's translucency, and yeah, that looks better. And yeah, that's what I wanted to do with this lantern. Let's play with lighting. Free. Yeah, we can see more lighting here, but actually I'm happy with one. And also we can set zero intensity to dome light, and we see these fake caustics here, I mean shadows from this lantern. Looks good. Let's bring back and let's render this with XPU. That's what we have. Reflections, diffuse, transmissions, and translucency. That's what we are going to use in comp later. The next assets we're going to work with are bicycles, and in this case we will need to make setup more complex because we will add variants. Let's have a look how it works in the end. And here we have a geometry layer which I used to construct layout before doing some shading, and we already have variants included in this geometry layer. Let me show you this. How can we explore variants? We can go to the scene graph tree and just right click on this asset, and we can see a variant set called model. Also, we can see all the variants included in this variant set. Let's, for example, choose this one. Set variant node created, and we can choose variants. Okay. Also, we can use asset reference node, and in variant tab we can set variant set name and variant name, all the same. Okay, and the next question is how can we add variants to the variant set, and I mean add variant to asset. Let's go at the top of our setup and let's start from something really simple. Here we have two component geometry nodes. This is the first variant, and this is the second one. Okay, here we got structure, and for this component geometry nodes I needed to specify only name attribute instead of full path, because component geometry, as I already mentioned, creates this base structure. Okay, the first and simplest way is add variants to new primitive. Let's plug into this multi-input and see what we have. Now we have this primitive created in the root, and actually it already has this variant set called model and these variants, but I do not want this name. I want the name from these assets, and in this case we can just copy this asset name and set it in primitive path, and here variant source primitive, and now we will have this root layer asset. Yeah, everything works. Let's choose the first primitive. We can see set variant node created, and everything works well. This is the first and simplest way. Let's do something else, and how else can we add variants? For example, component geometry variants, and both component geometry and component geometry variants nodes are the part of component builder setup. Let me show you this. This setup side effects offers to us, and actually it works really good. But we will need only some parts of this setup for bicycles. Let's just delete this. Okay. What can we do here? The same as in previous, just plug in here. And the variant set called geo, I want it model. Good. And we'll have all the same. Yep. Yep, everything the same. Also, we can do some tweaks in component geometry nodes. Let me, for example, call this bike 1 and this one bike 2. In this case, we will have variants renamed, and we will need to do the same in the set variant node. Yep, everything works. Okay, and what if we have more geometries? We can do the following: just copy and choose another one for this, for example, and so on. Let me rename this, and now we have 3 variants. Okay, but what if we have 10, 20, 30 geometries? Of course, in this case, I don't want to work with 20 or 30 component geometry nodes, and in this case, we will need to do something more efficient. Let's dive inside the folder with bicycles and see what we got there. 12 geometries, and actually these geometries were FBX format, but before working with bicycles I converted every of the geometry into BGO format. And what we want to create the setup which will load every of these geometries and put them in variant set. That's what we are going to do. For this, I'm going to use a component geometry node, which we already have here, and component geometry variants. Why am I going to use them? Because inside of these nodes, we already have some useful scripts, which I want in this example. And let's dive inside. Here we can see quite a lot of USD stuff, and actually we need only this part, because as I remember this part about materials, and I'm not sure about this one and this. So if we are not going to use component builder setup, then we can just take some parts of this setup and use it. Okay, let me copy it first. I'm going to delete all of this. I don't need this. Let's move it. Actually, I don't need this too. This one is just switcher if no inputs. I'm not going to use this one, and restructure we will use it but later, and not reparent. Yep, and I think we can delete this one too. And you can see that we deleted almost everything, but that's exactly what we need. And let's check why it is not working now. And yeah, let's talk about what we have in these left nodes. First of all, it's add variant node, which we already seen before. Let me show you. It's all the same, but another color. Okay, and let's have a look at this fetch. This fetch node reads inputs, and if we see, it has script. I don't want to miss the script, and I want to use it. In this add variant node, we also have variant name string, and this is a script too. If we see it, we will see the script. And let's check what we have in the end. Let's remove this. We have 3 component geometry nodes which are plugged into this input, and let's check if we still have variants. Yeah, we still have variants here. So we removed almost everything here, but left only necessary. And we will tweak some things here. Okay, let's put it here. So the next step is I want to assign the name of this root asset primitive the same as in asset name on this null. So I want not asset, I want Tokyo bike. what we can do, we will copy this asset name, and after that we go inside, creating restructure send graph, and here we specifying some primitive paths. Here we need to choose root primitive and rename primitives. New name is not this one. Copy and paste relative references. Yep, Tokyo Bike, and now we won't have variants, because in this add variant node we will need to change this primitive path. Now it's not asset, it is now the same as here, and this is all the same, right? Let's check it now. Yeah, now we have these variants here, and asset called Tokyo Bike. But in this case we will need to specify primitives here, model, and yeah, all works well. The next step is reading files from folder. We need to read these files and iterate over each of them and add to the variant set. Let me remove this one. We will leave only these two guys. After that, we will need for loop for each. Let's plug it into the third input. Let's look at it. Iteration method, and in this case we have some options for number of iterations for each primitives, and we need the last one for each string in parameter. Let's choose this, and we will have this option enabled, iterate over strings. If you read it, you will see that we need the list of strings, and this loop will iterate over each of these strings. So how can we create this list? I already have this small script. Let's just copy this and talk about it. Alt-E, and here we can choose Python expression and paste it here. What we got here, it's a really simple script which imports two modules, OS and Ho. After that we read in the folder in which we have geometries. Let me show you. We have it here. I just specified the path to the folder. And the next step is evaluation, because we need to read this parameter. After that we create an asset list and create an asset string, because this list contains brackets and commas. We do not want them, and we need just a string with spaces. That's all we need. After that we return that string, and that's what we got. And now this loop will iterate over each of these strings. What can we do with this information? Actually, we already have names for every of these assets, and these names are also iterations, and we can read these iterations with this option, iteration value. We can use this option, and for example we can name our variants, and we can set paths for this file cache node. Let's do this. First I'll try to do variant names, and in this case we need to do it like this, is if I remember correctly. Let me double check it. Yeah, let's just check it. Okay, iteration value, and after that we may want to create a string. Let me create string here and call it asset path. Good. And we need to construct this asset path from the path to the asset folder. Let's copy this. And we need to use this iteration value, because again, this iteration value is for example, for first geometry it's by extent 1 bgeo, for second by extent 2 bgeo, and so on. This is our files. Iteration value, and let me check how I did it. All right, the same way. And all we need now is to copy this and paste it here. We will need to wait a little bit, and it's things. Okay, and let's check now what we have. Right click, model, and yeah, all the variants here. Let's check it. Let's double check. Yeah, everything works well. But the only thing I don't like here is that I have this bgeo in the name of the variant. How can I remove this bgeo? Let me see this string, and that's just a string replace expression which I'm using. We're replacing bgeo with nothing, and in this case it will work. Let me just copy this. If I remember, I need to specify it here. Now we can't see any variants because now it has another name, right? Everything works well, and actually that's it. We constructed the setup which reads every file in folder and puts it in the variant set. After we have all the variants set up, we can go to materials, and I'll use this one because all the same, and after that we can use set variant node. I'm using it to set default variant for geometry layer, and I'm using variant name index instead of variant name. Configuring geometry layer and going to materials. Let's dive inside material library. Here we can see all materials for all primitives. Let me show you this, a lot of primitives, and let me check 27 materials for them. After that, we need to iterate over every of variants in variant set and assign materials to them using this assignment. Here we have all the primitives and all the materials. For this we can use for loop, but some things I wanted to show you here. For example, I can use this option, let me find it, for each variant in first input. But for some reasons it not works for me. Maybe I'm doing something wrong. I tried, but nothing. So in this case I just decided choose for number of iterations, and we have just 12 iterations over every of these variants. That's what I did, but not single, all iterations actually. And after that we have all the variants with materials. Let me show you. For example, this one we have these assignments, this one or this one, yeah, all the assignments here. Also we can see empty primitives here because for example in this variant we have one set of primitives, but in other variant we have another set of primitives, but we can see these empty primitives from other variants, but anyway material assignments are here. Alright, after that I'm setting default variant for material layer. Actually that's all the same as this one. Configuring material layer, and after that just saving the final USD. And let's have a look at the result of the layers. First I'll check geometry layer. We already seen it. Yep, everything here. Let's Let's choose another one, this one, and here we can see primitives, and here we can see other primitives, and so on. If we, let me do like this, if we see a material layer, then we will just see these assignments. If we combine them, we will have final use this. And let's render these bicycles. Let me use asset reference with final use this. And let's choose, for example, the first bike stand. Or maybe let's use this. Set variant. Let's use second bike stand. I'm going to use it with XPU, and let's try. It will need some time, I think. Yeah, it's still loading, and everything loaded, I suppose. Yep. Let's disable background. Oops, I think it's here. Yep. All works well, as you can see. Let's disable material layer to check. Yep, no materials, and now we have them back. But it needs some time again to load everything. Yeah, looks great. Let's check diffuse, contribution, reflections. Yeah, you can see these bright reflections and they looks really great. Transmission, we do not have any transmissions here. No codes, of course, and yeah, that's all. Let's have a look from the other view. Yep, everything works well. And that's what I wanted to tell you about preparation of bicycles asset. The last asset we're going to prepare in this part is road. Let's play. And in this case, we're going to work with camera because I want to see details on the road from camera view. Also, we can see these borders from buildings, and I added them because I want to see where ends the visible part of the road. It will help us. Let's have a look at setup, asset name, structure, geometry layer, material layer. After that, we applying some render geometry settings, I mean displacement settings, and camera, referencing camera. After that, sublayering these borders from layout scene, and that's it. Let's go inside SOP create. Here you can see how it looks. Let's start from the beginning, from this file cache, and we can see two geometries. Let me show you them. And yeah, we can see these two geometries. Actually, I'm using only this one, and we can see textures, but I'm not using them. I just use these white lines for my shading. Instead of these textures, I'm using megascans. I'll show you it. Yeah. Removing one of them and aligning, moving to the center of coordinates, and copying. And after that, after some more operations, in the end we have three parts. First is displacement parts. I mean, that's actually visible road, and we will apply render displacement on these parts. After that, we can see no displacement parts. We will need them for shadows mostly. And let me show you. This bounding box is some kind of proxy water, which we will pass to FX later. And actually we will use for water shading too. Okay. In the end, I'm saving it as BGEO. and pass into lobes. Let's have a look at it in lobes. If everything is all right, then we will see them here. Right. Let me show you them. This is visible part, for which we will apply displacements. This is invisible part, and this is water proxy. Yeah, everything works well. And let's have a look at shading. Let's dive inside material library and see what we got there. I will use this section, and we can find the water material and rod material here. Let's have a look at the water first. Water material is just MarterialX standard surface with transmission, and also I set depth parameter and color. If you are setting depth, then in this case you will need to set the color value to something lower than 1, and in this case you will see depth attenuation, depth color attenuation in water. That's how it works. Nothing special here. And that's rod material. And actually I'm not going to do it from scratch. Instead of this, we'll just point out some interesting things from this setup. But before going further, let's disable displacement for now, switch to CPU, and also I want to hide water surface and big part of this rod for now. Let's do it like this and press render. Yep. I started with these white lines and with this white sign. Actually, we already have these lines on original texture, on this one, and I just used luminance and remap operation to key these white lines. And let's have a look where we can see it in refraction. Alright, it's just a refraction OV, it's not a contribution. Okay, yeah, that's what we see. After that, I downloaded, let's pause rendering, I downloaded this texture, sign, yeah, and applied this sign to the rod, and where we can see it. And after that, I just mixed these two masks, and we can here combine these two masks, and we can see them in opacity. Yeah. But also we can see on the both we can see these masks on the both of these rods. I don't want it to be here. I want it only on main rod. And for this I importing attributes from SOPs and applying them, just multiplying, and we can find it in height. Yeah, and now we have mask only here. After that, I'm using these masks to mix in materials. Actually, just two materials: white painting and rod material. Alright, for rod, I'm using two texture sets. One actually, but from second texture set, I'm using displacement. Let me show you these textures. Albedo. Yep, I'm using this texture. I think this one looks really good. I'm using roughness, height map, albedo, and maybe something else. Roughness, height map, albedo. Yeah, that's all. And from other texture set, I'm using displacements. Let me show you this. And this displacement map I'm using for these cracks. Yeah. And one more difference is that for first pack of textures I'm using EV coordinates, and for second, for this displacement, I'm using tree planner. And I checked it works really well with both CPU and XPU. After that, I'm mixing them and plugging into displacement. And let's have a look what we have with displacement. Let's enable this and restart rendering. Actually, we won't see any noticeable displacement here because this rod now is quite rough and it won't be so noticeable. But we can see some cracks here. Maybe let's have a look from this view. But we will need to restart. Maybe we can increase this displacement amount just to see how it looks. Yeah, now we will see these cracks. But that's too high. This value is too high. I'll make it 1 back. Yeah, now we can see these cracks. Okay, let's set it to 1. And actually, this displacement will be more noticeable when we make the water renderable. Let's make it renderable. And I think in this case we can do the same with other parts of the rod. Let's restart. Yeah. And now let's look from this view and restart rendering. And now we can see these details in this transition from water to rod surface. We can see these small details inside the water, let's say so. And what else we need to do here? We need to do some kind of wetness, and for this I'm using unified noise with 3 levels: small scale, mid scale and large scale. After that I just combining them. As position for noise I'm using MarterialX position and object space. Let me show you this mask, and where can I find it? In metallic AOV. Yeah, this is noise for wetness. How I do wetness on this rod? I'm using a coat layer for this, and also I'm using these parameters. Let me show you how it works. Setting to 1. As the coat roughness, I have just rod roughness multiplied by 0.5, so just half roughness of original rod texture. Let's have a look at it. Now we can see these spots here. First, let's do like this, and let's go here and restart. Yep. And let's wait for the result. Yeah, I'm happy with this. Let's have a look at it. And let's render this from camera using XPU. So the rendering completed. We can do snapshot and have a look at this rod closer. What can I say? Actually, I'm happy with this result. I like these small details in transition between water and rod. I like these wetness spots, and I think overall it looks good as for me. That's all I wanted to show you in this section and in this part. I hope it was interesting for you. See you!